好，那个就不等人了。
This is the day the Lord hath made. Oh, this is the day the Lord hath made. Oh, yeah. Ah, come on. Oh, this is the day. This is the day that the Lord hath made.
His Excellency Mr. Abdullah Hamdok, Deputy Executive Secretary of the United Nations Economic Commission for Africa, distinguished invited guests of the Global Geospatial Conference 2013, distinguished participants of the conference, ladies and gentlemen. On behalf of the peoples and government of Ethiopia, it is with great pleasure that I welcome the international geospatial community to Addis Ababa, the capital city of Ethiopia and our continent, Africa. It is a great honor that Ethiopia plays host to this global geospatial conference in this historically significant year of our continent that commemorates the 50th anniversary celebration of the establishment of the Organization of African Unity. As mentioned in the theme adopted for the celebration of the Golden Jubilee of the
Thank you, Chair. Good morning, everybody. Excellency Dr. Abraham Tegesti, State Minister of Finance and Economic Development, Federal Democratic Republic of Ethiopia, Professor David Coleman, President of GSDI Association, Mr. Cyrus.
This is the day the Lord hath made. Oh, this is the day the Lord hath made. Oh, yeah. Ah, come on. This is the day. This is the day that the Lord hath made. I will rejoice and be glad in
看到这个是一个很现代化的一个会议中心哈，那是在联合国在非洲所建立的一个现代化的会议中心，大概成立也不到10年吧啊。那可以看到整个非洲的那个进展非常的快啊，那尤其是 GIS 对非洲的那个经济发展是扮演很重要的这个角色啊，所以来参加的这个都是各个非洲国家的一些重要的官员啊。刚刚也看到是伊索比亚的那个经济部长在致辞啊，所以它的整个层次已经提高到政府很重要的这个层级。当然。
To make that framework grow and evolve over time. And so our next speaker, and in fact GSTI's inaugural Global Citizen Award winner, is one of those persons. Probably the highest compliment we can pay him is to give him an introduction that reflects the immediate recognition and respect he's earned from all of us. And so, ladies and gentlemen, we're pleased to welcome Jack Anderson. Thank you, David. Thank you very much for inviting me here. It gives me a lot of pleasure to be with you. Some of you are my old friends. Some of you I have not met before, and so it's great to be with you. It's also great to listen to Jackie's presentation. It thrills me every time I see how her mind is working about creating a better future, a more sustainable future. My work is largely rested in technology. That's where I have spent my entire career. And I love that space. It's really quite exciting for me. What I want to share this morning is about what I think the next generation of enabling geospatial technology will be. I'll just refer to it here as WebGIS. Jackie has already talked about you, about who you are. In fact, the way I see you is as a kind of global network of geospatial professionals. For whatever reason, for whatever discipline, you are here, I think, sharing information about your work and connecting. This is very powerful because while my work and people like me building basic technology is important, your work in the actual fabricating of organizational structures and creating enthusiasm for building SDIs, a kind of geospatial platform for geography, is, I think, more difficult and in many ways more important. As Jackie reflected her thoughts, our world today is in serious problems. We are challenged on almost every front. You've thought about this, I suppose. Sometimes we go unconscious about it. But clearly, we need to step up to taking more responsibility. We need to start to plan. These challenges need planning. And they need planning beyond our little stovepipes of activities. Or it isn't going to work out. It's clear as that. You probably think about it a lot, I suppose, with respect to children or your friends. It probably isn't going to work out. That's the bad news.
And if these trends continue to accelerate as they are, it isn't going to work out. That's just the reality. To be able to change it will require all of our best thinking, our best science, our best technology, our best design thinking. It will take us pausing, building on the kind of organizational fabric that each of you represent in your own organizations. I think it can work out. I'm a positivist. That's what runs my life. On the other hand, we do need to think about it now. GIS has already contributed a lot. And it's interesting because it's an integrative technology. It's visual. It's science-based. It's quantitative. It lays out a fabric that allows us, with all of these ingredients, to cooperate and collaborate on creating a better future. Your work, the work of many of you, reflects exactly that experience. It provides a very practical means for creating the future. In thinking about coming here, I went through my head thinking, why is it that GIS is so compelling to Africa right now? I suppose it's always been compelling, but well, maps communicate. We heard from George about that. They tell stories. GIS is analytic. It allows us to do modeling, predict the future, do analytics about what's going on. And now, for the first time, this new generation of technology is providing the reach to bring this special, your technologies, into the hands of virtually everyone here on the continent. It delivers value. That's another way to think of it. It helps people make decisions, drive more efficiency. Many of the objectives which at the policy level Jackie addressed is now in the reach of our imagination with this new generation of technology. Some of you are working on issues of health, and others working on issues of nutrition, agriculture. GIS is showing up across Africa in environmental areas, water resource planning, water resource management, in conservation in South Africa, for example, and in eradicating polio successfully, almost, in Nigeria in the last couple of years, thanks to the generosity of Bill Gates and his wife. GIS is helping us with agricultural planning, understanding where to plant what with predictive modeling. GIS is used to engage citizens and provide more government transparency. These are not only noble ideas, your work is actually delivering on these ideas. GIS is also taking a shift. Its blending with the web has meant that many of you and your colleagues around the world are providing open data portals, sharing data openly, sharing data as services to drive efficiency in your own organization, improving both the insides of organizations, but also sharing outwardly. And the good standards work of ISO and OGC and others are ensuring that these are available and open for technologists like myself to exploit and deliver value on every front. Clearly, GIS is changing how we think and also how we act. These words represent some of your disciplines. GIS is providing a framework for measurement, whether it's synoptic measurement or GPS measurement. It's a framework for predicting and analyzing and designing and planning and evaluating and decision-making and moving these words into a workflow. Clearly, this technology, the work that you do, is having an effect. On the other hand, this effect is relatively narrow, often project-based, sectorially oriented. As the Deputy Minister mentioned this morning, we need to scale it up if we are going to turn it around. You might think, can technology really create transformation like this in the way that we think or operate? It's an interesting question. Can it actually have a huge transformational effect? On this device, I have a GPS, and so I'm never lost anymore. I can look at high-tech satellite imagery, see where I'm at, and use GPS, and billions of people on the planet are no longer lost. I call that transformation. I'm no longer afraid anywhere I go. I can always find my way around. I'm never lost. That's an amazing transformational event with our technology. I say our loosely, technology. How can we scale up the powerful, integrative, and quantitative technology of GIS so that we can be never lost in terms of creating a future which is sustainable? That's an interesting question. Is it possible? I would assert yes. GIS is also being transformed. It's going through almost a complete revolution. It's integrating, it's leveraging lots of things. The cloud, the web, again, the Deputy Minister mentioned some of these. It's integrating massive content, 3D content, measurements of all type. And out the other side is popping the world of apps that farmers can use with no GIS education, that planners can use to never get lost, because they can consider all of the geographic information in their decision-making, in their thinking, in the way that they analyze the future. This is not only a powerful vision, but the technology is coming together to deliver on that vision. It's transforming GIS from a simple mapping system or a personal research system to a platform that can scale up and make geographic knowledge available, as the Deputy Minister said, anywhere, anytime, for anyone. WebGIS, what I like to call this, makes GIS all of the complicated information tools available on any device simply, easy to use, sort of slippy, interactive access. And we are experiencing that people learn how to use it by using it, not in the classroom, like the classic way geography and GIS has been used. This WebGIS pattern supports broadly two kinds of community. Traditionally, we've talked about the GIS specialists, or the geospatial specialists. You know these people. Many of them are you. And then more broadly, the business or consumer type of user who is interested in just making maps or doing analytics, but not as sophisticated as the GIS analyst is, or the young entrepreneurs who are interested in developing on this kind of platform. This kind of platform unifies these two worlds. The WebGIS brings them together so that we see scientific and high-end application knowledge shared by everyone else through the kind of easy-to-use platform technology of the web. WebGIS platforms support everything. They support the GIS user with cloud web services of mapping and analytics and sharing between them. It also supports the simple mapping and simple analytic community, as well as the enterprise community of ERP or business intelligence. Our colleagues in the IT field can simply plug in maps and spatial analytics into their traditional information system. And it's also open, standards-based. It's also running on any device. It's also accessible from the whole world, the new pattern of apps that our societies globally are interested in using. These web maps, this WebGIS is built around web services, standard-based services and web maps. They can read in traditional digital maps and services, imagery, but also they can integrate just as easily tabular data, be it Oracle databases or simple little spreadsheets. They can integrate social media. They can read in the sensor names, and they can integrate with GeoWeb services, big data as services. This environment provides a kind of new architecture. Traditionally, the architecture of GIS was centered around DBMSs, where we organize all of our data into one central data bank and transactionally update it. That architecture still remains, and it's very valuable, particularly with authoritative data sources. But the new architecture complements and extends that architecture with distributed web services such as data-centric solutions, but also, for example, the web, and also, for example, social media, and also distributed services from each agency, a kind of architecture for unifying a whole country of distributed data sets. This is interesting architecture because it means I don't have to put everything into one integrated data bank in the beginning, which is difficult, as many of you know. Hard to get everybody to agree on one ontology or one data structure or one computer center. This kind of architecture is interesting because using web maps and web services, I can bring things together dynamically. Using 1990s technology of hyperlinking, I can link documents to objects on the map. The mashup technology brought to us by the music industry allows me to visually overlay maps from distributed services. And this year we've seen the emergence of spatial analytics using web services, analyzing one layer with another layer from distributed sources to provide insights into relationships and patterns and modeling. Do you follow this notion? So we're moving literally from this notion, which is relatively difficult to accomplish, to a more agile architecture which realizes the vision of GIS in the first place. This WebGIS not only affects how we integrate the data, it also affects our organizations, which I know many of you are particularly interested in with respect to SDI. We move from stovepipe, difficult to orchestrate organizational architectures to the ability to dynamically share and integrate geographic knowledge on the fly. And many organizations are beginning to try this and work with it successfully. Jacqueline's work with Eye on Earth was one of the first ones with the European Environmental Agency. But in the private sector, large organizations such as Shell Oil, or in the public sector, in my government, something called the Geospatial Platform, or in Indonesia, the NSDI is being built with this new generation of technical architecture, which is far cheaper and more agile and open and standards-based. This WebGIS pattern supports the notion of enterprise architecture within an organization, but also for many of you, between and among organizations. As I mentioned before, connecting the geospatial professionals with the knowledge workers or the executives, department managers, the president, the big guys, as well as citizens, and on any device, and integrating this knowledge into our colleagues in the IT organizations of our agencies and companies. GIS has had a long history. Today, it supports, at the technical level, 4 main patterns. The first pattern, and perhaps most pervasive, is the desktop pattern. Millions of users use it every day. The second pattern is a data-centric pattern. Put everything into a database and you can access it. The third pattern is a services platform pattern where analytic services and mapping services are managed in a server-centric environment with apps of various types accessing. This fourth pattern, the pattern I've been describing, is a fourth pattern which unifies the other 3. It brings together distributed servers on-premise, complemented with cloud services, organized with portals, and accessible from any device. This fourth pattern actually unifies the other 3. It doesn't obsolete it. Desktops become thick clients accessing services. Servers serve content on premise and so on. It brings it all together. It doesn't disrupt current activities. In fact, it enriches them both at the client and the server side. Dynamic services come alive and are able to be unified. This web architecture pattern is accessible from any client with open APIs. It's powered by content expressed as services, mapping services, streaming content services, real-time services, analytic services, both hosted in agencies individually and in some cases as appropriate in the cloud. It organizes this content through portals, open, simple, distributed, standards-based. Unlike GIS in the past, this kind of GIS comes with content. Content, for example, demographic content, or base map content, base maps of the land, base maps of the ocean, that are ready to use instead of having to build them. And primarily content which is shared by and for agencies or organizations. It's a sharing concept, not a proprietary concept. Base maps are the heart and soul of that. They are the base maps on which operational information can be associated. And it's served not only from one big database in the sky, but thousands, actually hundreds of thousands, eventually millions of servers that associate individual contributions. For example, national mapping agencies serving their base maps or their content for others to use immediately. Not giving up rights, not compromising the content in any way, owning and sharing. Thematic agencies like forestry, water, being able to share their content as operational overlays that can be mashed up and persisted and analyzed to create interpretable results. Accessing these services are apps that are free, usable, easy to use. Apps for mapping, apps for viewing, apps for data collection, apps for analytics, apps for common operating pictures, apps that tell stories, apps that are authored by young entrepreneurs. Simple, open, fast, performant, available, just like we've seen with the revolution in music from Apple. You see the Geo coming in the same domain. I could talk about this a lot, but my colleague here, Clifford, is going to actually just show you a pilot that we did for all of Africa so that you get a sense of what it's like. Clifford, can you have a mic down there? Yes. Good. Oh, thanks, Jeff. Hi, everyone. Clifford is from Kenya, so he's a little nervous, so would you welcome him? Thank you. I would like to show you the cloud-based, web-based GIS and what our colleagues have done in using ArcGIS Online and the digital atlas that we are building for Africa. So, as we provide rich base maps that are really comprehensive, that you could use for your work, be it to emphasize on streets or terrain or even the oceans. You could use different base maps for this. Or you just need to use imagery as a backdrop for your work. There are really rich sources that have been given, generalized at different scale levels. So as you zoom in, you get different information at different scale levels. At the same time, Esri is really working hard in improving the imagery content for the whole world. Like last year, Esri added about 100 million kilometers square of high-resolution imagery for the whole world. There's about over 2/3 of the world landmass. And these imagery, you use them for very many different works in your areas of expertise or in your industry. For example, they could also help you to understand how our world is changing. Take a look at Ethiopia or Addis Ababa in the year 1990, and using a simple tool of swipe, we will see how it has changed for this is the year 2010. Perfect. This is Landsat information for the last 40 years for the entire world. So you can not simply have a picture as a background, you can actually do analytic services against Landsat, which is a free contribution of my government as a web service not simply as a picture, but actually manipulating full multispectral data. It's all up there now available for you online. Sorry,
thanks. No problem. At the same time, we're also working with the elevation layers, which use different services or layers on the fly. For example, you need to work with the hill shape, and just on the fly, you could be able to have your hill shape displayed, or you could also need to work with the slope. Just on the fly, you are able to get the different imagery from these services that are available for us.
What's remarkable about what Clifford is showing is this is computing on the fly. Slope is not stored, elevation is stored, and computationally from the cloud, elevation is looked at and slope maps are created, or aspect maps, or watershed maps, or drainage maps. So it's a different pattern than we're used to. We store the raw data, like imagery or elevation data, and we compute at the time of viewing or the time of analysis. More on that in a moment.
Great. With WebJS, we do very many works in different industries. Be it in health, for example, mapping the locations of health centers in Ethiopia, given their capacity, or you really like to assess the prevalence of a certain undernourishment for the whole Africa or for the whole world. For example, you can see what's happening in Kenya, for the period ranging from 1999 to the year 2012. And you could also see something happening also in Saudi, in Sudan, where this percentage is really increasing instead of reducing for those years, that period of time. Apart from that, you could also understand or map the hazards that are taking place. For example, the locust invasion hazard that happened in Madagascar early this year, that is March 2013. And with these, each and every web map or application that we have over here, they are accompanied by pop-ups that you could also read and get more details. Even the conflicts that are taking place or that have taken place with time, for example, in the North Horn of Africa, that the conflict has taken place also in Somalia and many other countries. We could also map this and many other things that our users and also colleagues are doing. The next thing that I would like to show you is a very interesting tool, a landscape modeler, that we have developed to do on-the-fly modeling for Africa. So it has been made by very rich layers that have been built, elevation, land cover, and many others that we use. And each is accompanied by rich metadata that could be given the source and many other information about it. With this landscape modeler, you could, for example, I would like to determine the maize harvesting suitability for Africa in the year 2050. So I have a model here that I created that helps me to understand this. So what I do, I just load and run, and this model will do it on the fly. Remember that it's doing weighted overlay analysis, giving each and every layer weights, and each and every layer also the attributes in it has also been weighted from 1 to 9, where 9 are the highest weights or the best, and 1 is the least or lowest weight. And each and every layer is done that. And on the fly we get our results that I could also add some layers, for example, for Ethiopia region, so that I understand more what is taking place. And there you go, I have my layer has been added over there. And something is interesting, we like charts, we like graphs. I could also load my charts for this particular region. And at any one time I click on any of my charts, I get another chart that helps me to understand the maize stability for each and every region that I have on my map. So see here is that WebGIS is changing the way we do things and is also changing things. At the same time, it provides us easy to use and rich, ready to use content. And this content, they are all in the cloud and also other sources that we can use to make efficient decisions at any one time, effective decisions, and also helping the technical staff to get results on the fly or as quick as possible. Back to you, Jack.
Thank you. Today, we see about 100 million of these maps a day made. This is not a research project. It's very actively going. Of course, it's not as fast as Facebook or something like that, but it's incrementally being understood by GIS professionals and also millions of business users. We've seen demos like this in the past on desktops or client-server environments. There's nothing new from a science perspective that I've showed you. What I have showed you is the notion of distributed data sets being able to be integrated, manipulated, and interpreted on the fly, over the web, available on any device, anytime, anywhere. When I first realized what would happen, I could hardly wait, because I know what this will mean for Africa. It will mean that we can do analytics, like Clifford showed, without the necessary hardware and software or even complete GIS training. We'll be able to do it simply. We still need science training, of course, and understanding of what we're doing. But some of the barriers that have held us back in terms of disseminating the technology, never being lost, so to speak, are falling away. This technology can empower a whole new generation of developers, young people who are across Africa who want to use simple content and APIs to invent the solutions to those challenging problems. This technology can be used directly in schools with simple web browsers to create a whole new generation of spatially literate kids. This technology, I think, will transform our world. I'm not sure. I'm hopeful that the visions that you and your colleagues have had for years of delivering on the geospatial promise can be realized by this technology platform. And improving collaboration will be one of the outcomes of it. Improving communication will become one of the outcomes of it. Better decision-making is essential. And I really, like I said, I really, for the first time in my life, feel it very close to actually realizing how we can deliver on the potential. WebGIS is, I would simply say, an evolutionary step in our field, whether it's cartography and mapping, or whether it's earth science, or whether it's measurement, or whether it's land use planning or decision making. I sense that we're about to make a huge step in how we can deliver not only unified geospatial information, but also effective ways to get it out to our colleagues. Let me complete with these thoughts, perhaps. We definitely need to create a better future. It isn't going to work out if we don't get it together soon. Do you agree with me? I mean, how can you not understand that it's not going to work out if we don't get it together? And we need to do it for our families, our organizations. I suppose you might say in abstract for the planet itself. I relate more to my family and my community and my country. is already doing a lot. I mean, the very important work that each of you have done in projects and setting up systems has given us the evidence that this is actually a powerful technology to work. I think WebGIS will accelerate that. That's my strong belief system. Embracing this pattern will be important. Just observing it as casual, observance isn't going to do it. Embracing it, figuring how we can actually integrate it into our workflows and how we make decisions is going to be essential. That's why I'm so pleased to be able to talk with you this morning, because you actually, more than anybody I know, work on that all the time. So thank you, ladies and gentlemen. I appreciate you and David for
好，我想透过他的这个演讲啊，当然比较清楚，现在整个 GIS 的这个技术，整个在做一个翻天覆地的这个改变啊，就是把以前很多散在很多各个地方的许多的这些资源啊 ，GIS 资料库等等啊，透过网络啊，透过 Web， 透过 Cloud 啊，透过各种那个网络服务 Web Service 啊，我们可以看到很多东西都开始整合在一起了。那在网络上有越来越多的资源，你很方便的、很容易的就可以取得到，啊，那各式各样的这种服务啊，越来越方便，所以这个现在有许多的这个资源，很容易的就可以拿来用来做整合啊。我现在介绍一个网站给各位看一下啊。这是台北市最近推出来的一个台北市历史图资展示系统，那这里很方便的把这些历年来的他们收集到的这些航空照片，就很方便的就可以展示在这上面，你可以看到很老的，各个年代的。那你也可以看这个新旧对比的这样子的，方便的这样子的工具你可以看这些都市的这些变化在这几年是怎么样子在改变那这些都是大量的地图影像、图资在很多不同的这个地方那现在这些都已经慢慢进到资料库里面去了都已经进到云端的。慢慢都会进到这些云端的机房里面去，那现在也很多的这样子的资料，就慢慢就变成各式各样的服务变各式各样的服务让你很方便的来取用你只要做 mash up 就好组合、接用那怎么接用这些资料呢？我们以前有用过那种所谓的那些。WMS、WFS 等等这些有些要把图资整个传回来，像 WFS 那个可能就不太有效率那现在大家慢慢习惯了用像 WMS 我只是取得影像你这边应该看到的是一些 WMS 的东西，或是一些图砖的他用图砖的方式发布这个服务，所以 你不需要拿到这个资料，可是你可以用这些资料，也很方便，啊，你就可以做这个 mash up， 好，那现在有更多的是把它整合成 API， 就是它的整个系统的这些功能呢，就会开发成 API， 好，那你只要它就是几行的程式，啊，你把它的 API 的程式抠过来，放到你的网站里面，啊，你就会有这样子的这个。各式各样的这种服务可以在这里面看到。那它这边也有3D 的这个整个台北市的3D 的这个建筑这样子的服务。那这背后的资料库都是蛮庞大的，可是现在透过网络的这种方式你就可以很方便的这个取用。这些资源让你能够很方便的来使用各个地方已经建好的各式各样的资料库进去看一下这个3D。可以看到这些，当你 run 进去的时候，这些建物3D 的建物就会起来了。这个图片库比较接近这个建筑物的外形，外观它是这样去把它贴出来，这种感觉也是不错了啊。那现在有很多真正的是用飞机去照外面的那个照片，然后再把它贴到这个建筑物上面去，那就更真实啊。那这些都是很好的资源，就是一堆这种网络上的东西哈。现在看的是它的一个系统，所以你必须要 log in 它的系统才可以它的功能。可是有 API 之后，你就可以把它整合在一起。这个是一个很有用的一个网站你可以看这个整个历史的这些变化啦，历史的图资，那它还有很多的地图。
Since nearly the beginning of human history, maps have shaped the world we live in and marked important milestones in our advancement. Cavemen drew maps to help remember where to hunt and gather. Expert cartographers charted maps to help explorers navigate little-known places and define borders. Scientists mapped space to help mankind reach the moon. Today's digital maps are more sophisticated, but some things haven't changed. Our maps still help us get to where we want to go, guide us when we're lost, and perhaps most importantly, give individuals the ability to change the world. In 2005, Rebecca Moore used Google Earth to illustrate the impact of a planned development and convinced her community to come up with a better alternative. From this effort, Google Earth Outreach was born in order to give anyone the tools to change the world with maps. Since then, different people and organizations have been creating real, long-lasting social change using these tools. Their maps help to protect the environment, provide better crisis response, improve safety and save lives, and even preserve a culture. Through Google Earth Outreach, these organizations are using digital mapping tools to write their own chapter in history. Google Earth Outreach. How will you use maps to change the world?
这个是一个很棒的这个网站哈，那它这里把 Google 的很多的跟地图有关的这些工具 API 都整合在这里啊，所以你这边看到有 Google Earth 啊，那 Google Earth 它是一个3D 的啊，可以让你飞进去去看啊，去整合，然后把 Google Map 的这些卫星影像啦、地图啦等等都整合在一起，是一个3D 的一个图形展示。那 Google Earth Engine 呢，它是结合那个卫星影像，就是美国的 Landsat 从1972年就开始拍摄地球的这个照片，那现在经过已经40年了啊，41年了，连续每年一直在拍。那最近整个的 Landsat 的这些影像呢，通通开放在网络云端上面免费。以前每一个影像去买都要很贵的。你去随便去买一个Landsat影像，我在念书的时候，那时候买的那个影像非常的贵。那最近呢，这个美国政策就是把这所有的影像Landsat 40年来的，通通把它这个开放免费那你就可以做好多那种变迁的这个研究。
Landsat has become one of the more common sets of remote sensing images. It was launched in July of 1972. That started the process of continuous observation of the land surface of the globe. It represents the longest running record of the landscape of the planet that's ever been recorded.
The Landsat satellites pass over the same place on the Earth every 16 days. Their orbit goes from pole to pole and they capture a new place, and then every 16 days they start to repeat that. And it's been doing so for 40 years now, continuously orbiting, collecting data.
NASA takes the lead on the development of all of the space hardware. They build satellites and they put them in orbit. Once they're in orbit, we collect and distribute the imagery and ensure that the data are preserved over the long term.
Working with satellite data is important because we can monitor the environment and how it changes over time in a very consistent way. We can quantify the dynamics, whether it's related to agriculture expansion, fire regimes, deforestation, urbanization, and have a record that allows us to relate those dynamics to the drivers, population or economic policy, what have you.
It's really kind of an underpinning of what we need to know to understand the health of the planet.
One of the really big stories of environmental change is the deforestation in the Amazon. This whole area here If you go back to 1999, the vast majority of it is intact forest, and you can just see the herringbone roads come out through the forest, and then roads come out from those, and the land clearing and the forest disappearing.
The value of Landsat is in the use of the data. That means that the data have to be in the hands of users. In December of 2008, we completely rewrote our data policy to one in which all Landsat data were available to anybody without restriction at no cost.
So they opened up this archive, this treasure trove of data going back to the early 70s. We used to say we could only use the data we could afford, not the data we needed. Well, now we can have all the data.
The challenge, of course, isn't collecting the imagery as much as it is interpreting and applying those to problems, and that's simply a massive job.
And this is where the Google Earth Engine comes in. We have to have something like cloud computing to be able to analyze those data and quantify the changes. And Google provides the computing to match up and mine the archive. An example application with Google Earth Engine was done last December. We accessed over 50,000 images. We brought them in, we processed them with the cloud. If we had one CPU working on that, it would have taken over 3 years. We did about 15 hours.
I think the key to this partnership is that our data, being applied very creatively by Earth Engine activity, is really pushing Landsat to that level that we've all dreamed about over the years of its history. Landsat data are now in far more hands than ever before. When we start having simple-to-use tools that are proven, tested, and can be run by people with less training, then we'll make more progress. Earth Engine promises to be that simple tool that many can use.
它还有其他的像 Google Map Engine 啊，它可以让你把你自己的地图啊，把你的自己的资料啊发布成 Google Map 的一些形式啊，可以用到手机上面啊等等，然后你可以决定要给谁用啊。Tool Builder 这个是你可以把你的一些 project 的资料啊等等把它包装起来，然后用 Google Earth 的这些东西整合起来，把你的这个照片啦、video 啦等等这些相关的地图资料 share 给你的朋友。那 Open Data Kit 这个是让你去收集资料啊，你可以用你的手机啊去收集很多很多的资料，把它这个整合起来啊，变成可以用的这些资料。那 Spreadsheet Mapper 啊，就是可以让你用这个 Google 的 Spreadsheet 很多的资料，那把它展现成这个地图的这些资料，啊，可能收集到很多 GPS 的点位资料，然后这个各样的资料啊。那 Custom Map for Google Maps 啊，你就可以用 Google Maps 啊，建立很多很多你自己的个人的这些资料啊，然后你可以把你的这些各式各样的资料分享。就是用你去制作出来各式各样的这种主题地图。那 Google Map API 就是让你去接Google Map 这里面所有的这些卫星资料啊，各式各样的功能啊、地图啊等等啊，你就可以把它整合到你的这个网站里面啊。那 Google Street View 啊，就是让大家知道。先一个一个去看这些 tutorial， 你就会了啊，它就说明得很清楚啊。所以 beginning 的 tutorial 或是 old tutorial 啊， 看你要用什么工具，刚刚讲的那些工具都有这些教材、训练教材，这是 Google Earth 的 tutorial 那如何上面加注记如何 add photo image 然后如何3D 的这些 view 等等这些。
它比较基础的简单操作，就是在 GIS 在目前就是正在转型成一个 Web GIS 的这样子的一个变化的过程中，所以很多 API 就慢慢的开展出来，然后其中很多 Maps 的 API 就是在 GIS 中更是被丰富的运用。除了 Google Maps API 之外，还有 T-Ghost API， 然后 Marcosi API， 还有 OpenLayers API， 各种的 API 都可以供大家来进行更多 GIS 的分析，还有基础的操作。讲到 Google Maps API， 大家可以来看右边这些图。这些网站呢都是基于 Google Maps API 这样为基底来做成的。它已经打破以往可能纯粹只是展现一些点位图示的这种想象。比如说这个网页呢，它就来用 Google Maps API 把它加进来，它就用 Google Maps 来说哪里是情侣常去的地方，哪里是有爱产生的地方，这样子一个网站地图。然后刚刚影片中有提到 GIS 它已经可以超越了一些边界的限制，在这个网站里面，它就画了很多像这样子的图示来显示说，在各个国家区域里面的他们的海底电缆的运作的状况，还有分布位置，还有其他各式各样的使用 Google Maps API 来建制的网站，可以让他们的网站变得更丰富，也可以让更多的空间分析工具被用来操作。这样子的 Google Maps API， 它们都是建构在网站上面的，大家都是以 JavaScript 来作为基底而建构而成。除了可以做基底的地图展示，可以做卫星影像的展示，或者是地形图的展示之外，更重要的是你的资料能够有一个得以被显现的地方，因此就可以加入更多的空间分析操作工具，有了更好的决策的机会。而在这样的网站上面呢，你可以画出你自己要的东西，然后进行地址定位、导航方向的指引，或者是加入一些街景图的概念。 上礼拜2的时候 ，Google Maps 他们提出说他们的 V2 版本已经宣告到那边为止就不能使用。然后从上礼拜3开始呢，就是他们决定全部的 Google Maps API 都必须要用 V3 版本的这样的形式。在这个 API 里面，不同于第2版本是，在这个第3版本，他们的 API 是不需要 API key 的。如果你要的话，也是可以让你的操作更为稳定。可是在不需要 API key 的这样状况下，就可以让你操作的更简单，然后更方便，就可以来使用。所以以下呢，就来进行一些基础的，就是在该怎么做这样的讲解。好，我们就可以从 Google Maps 它的 Developer 里面的 API 的这个方法中，你可以进行你想要的各种的方法，然后来加入你的网站地图上，然后就可以建构出一个初始的网站。这个是我架设的一个比较简单的一个版型。在右边的部分呢，是我们的地图展示区，左边是各个方法 API 的运用。我在这里，我先暂时都把我的 API 的功能写成一个的按钮。其实你也可以在载入地图的时候，就把所有的 API 功能都载入进去。但是我觉得按钮形式更能彰显有跟没有的差异，所以我在这边用按钮的形式来跟大家做讲解。好，先看右边的这个地图区，我点选地形图，我会看到地形图的样貌。在左上角区域呢，我会来跟大家写说这个主要的功能是怎么样子的，而它主要的程式码，它当然程式码可能不止一行，可它最主要的建构，虽然只要简单几行，它其中的最主要的那一行是什么？好，这一行就是能够来写出这样指令这样的画面的一个小指令，所以在进行 API 操作的时候，他们的程式码其实都是简单的，就像老师所讲的，你只要把 copy 进来，然后可能再多做一点点小小的变化，你就可以做成你自己的网站。除了地形图之外，我们可以点选混合地图，来到另一个界面。这样界面是融合了卫星影像地图还有基本的路网地图而建构而成的，或者是你可以建构出你自己的地图。这样的地图是 Styled Map， 是刚刚在 Google Earth 的那个搜寻的老师介绍页面中一个 Custom 的 Map 的展现的形式。这样地图跟以往的地图不一样的是，你可以建构出你自己想要的颜色、色调、你的对比幅度、饱和度。比如说，我觉得原本的颜色可能没办法彰显我想要的区域，我想要显示的是跟原本以往地图不同样的样子，所以我就可以调整自己的色调，或者是像是这些 label。对于像我现在以台北市来作为我的范例区来说，这些过于细致的点位的标签，或者是太细致的路网的名字，对我来说是不需要不重要的，我可以这边把它做剔除，建构出一个我自己的地图的专案。而在这样的客制化的地图中，有很多的 feature 是可以供你选择的，你可以选择行政区的状况，你可以选择各个点位的状况，路网的状况，水域的状况。而这些 feature 的 type 里面还有更细致的分类，光一个 points 就可以分成政府点位、学校的点位、business 的点位，或者是各式各样的好多点位，你可以选择是不是要进行更多的展现。而展现可以用哪几种方法呢？你可以改变它 polygon 里面的颜色， polygon 外围的颜色，或是 polygon 的标签要不要显现，或者是标签的颜色、标签的背景颜色，有好多种的选项可以供你来进行选择。你可以进行各种的 stylers 的调整它的亮度，调整它的对比度，来进行设置一个你自己专属于自己的地图，你的地图的形式。好，在这样的界面中呢，还可以做其他更多的设计。比如说，我现在先看左边这个部分，这边这个控制链呢是 Google Maps 里面最常见的控制链，我们可以进行平移来进行地图的整个的界面的移动，或者是我们可以用小人把它拉进去，看到更多街景的设计，或者是我们可以点选加跟减来进行尺度的缩放。好，我现在把它放到这个台大这个位置，因为我现在以台大为中心来进行一个讨论的话，如果说我每次都还要移到这个中心位置，然后这样子是一个不方便的做法，所以我在这里呢，我可以把它台大这个位置给它设作中心。设作中心之后，我接下来我不管移动到任何个地方去，我只要按回到中心这样的按钮，不管在任何层级的尺度上，都可以回到你这个台大这个位置，就是你可以 自由的定定，让使用者自由定定它的中心位置，让使用者有更多的参与感。好，除此之外呢，先有更多的参与感。如果说我们在进行一个 PPGS 讨论会，或者是其他形式的说明会座谈的时候，我们可以用这样的 Google Maps 工具来进行更多的操作，但其中也不乏需要有一些空间的可能资料的建制，即时的建制。于是我在这边就设置一个 Draw Tools 这样的按钮，我给它点击下去，好，上面就会出现我们外挂进来的绘画的小工具。在这边我们可以做可能点的加入，圆形的加入，或者是a polygon、polyline 或者是 rectangle 这样加入。我现在加入一个，点选这个点，然后点在抬到这个地方，好，就展现出我的一个个点的分布状况。这些都是可以即时建制的，而且即时被保存的资讯。除此之外，我当然可以对其他的选项来进行调控，而这些绘画的小工具，你可以自己调控它的颜色、它的透明度、它的边框颜色，或者是它是不是要工人在建制完之后再来继续进行下一步的，比如说边界的调整。好，现在来操作，比如说要画，就画出去这个样子。这些每一个小小的圆圈，我在这边设计是可以来进行自己随意的拉扯或者随意的游移这样子的设计，所以就可以自己及时的建制出你想要的图示或者资讯，或者是空间的配置的样子。除了 Draw Tools 之外呢，我现在把它放到在这个信义计划区这样的尺度。在这样尺度中，我们可以借接别人的资料，然后来进行更多的即时资讯感测过后即时监控的结果。我点选 Traffic Layer， 它可以显示出即时的路网的到底是怎么样的路，是有怎么样的拥塞状况。绿色的话就是很顺畅的，可以走得很快的，然后红色的话就是很不顺畅，去那边开车骑车会很久的一个路网。这样的路网呢是全球性的一个分布，只要这个城市它有散步到的地方，我们都可以来进行这样的 traffic layer 的检视。除了 traffic layer 之外，我们也可以加入别种的图层，比如说这边可以加入这个 weather 的图层，于是就可以看到它的气温以及它的是不是下雨，是不是晴天这样的，以图示来进行更视觉化的这样的展现。除了 weather 之外呢，我们还可以再做更多的 weather 的控制的选项。我把尺度缩小，就可以看到这样云的分布，而这些东西都是即时的，而即时更能让我们了解现在的状况是怎么样子的。除了现在的状况之外呢，我们也可以对过去的状况做更多的描述，还有分析琢磨。比如说我在这边加入了 Taipei Town 这样的一个资料，我们可以利用之前 Geo Server 产生的资料来发布的图资来把它加进来，或者是你可以加入 KML 资料，也或许你可以利用再借接别的资料。我这边接上了 ArcGIS 它的 API， 然后用 ArcGIS Server 发布了他们的 Map Server， 然后再把它加进来，于是这样的图形就有了更丰富的展现，然后也能更让人了解到底过去的状况是怎么样，然后可以来跟现在的即时资料来做比较。好，除了资料图层的加入之外呢，因为现在 VGI 是一个很重要大家在探索的课题，现在 Google Maps 也很想要把更多的 VGI 资料给它加入，其中 Geotag Photos 像具有地理标签的照片呢，是他们觉得很能够展现 social media VGI 这样子的概念，所以我在这边就可以接上一个 Photos 的一个程式。好，我把它接进来，我点选 Photos On， 然后就可以让在 Panoramio 这个相簿里面呢，就可以把所有的资料都给它丢进来。这样的丢进来之后，虽然说我们可以进行进一步的可能点选它的资讯来进行展现，但是我们还其实更需要的是更细致化、更地区性、更符合你条件要求的图片的相片们。所以我在这边我就设置了这样的一个小方框，你可以这边加入你想要的 tag 的标签，然后来 find 找寻在有被受那个标签而标注的照片。我在这边以台北作为范例，我打了台北，然后点选 Find Photos， 就有了台北的照片，于是就有了更多的 social media 这样资料的展现，是一种更就是资料的融合的一个显现的方式。好，如果说我现在图字好多，然后 整个图示、整个地图的界面变得很混杂，我可以点选 Remove All， 让它回到最初始的画面。好，这些简单的操作呢，除此之外，当然这个版型也是你可以随时自己恣意控制的。那我就调整成一个我喜欢的样子。你当然可以加入其他不同的功能，比如说，如果说街景对你来说是一个很重要、必须要随时都能够掌控的一个条件，你就可以在这边加入了街景的这个因子，然后在地图初始化的时候，一载入这个网页的时候，就把这个街景给打开，这样子。或者是你可以用叠图的方式，我这边把这个图丢到了我的一个网络相簿，然后再把它接进来，用加入 JPEG 档案的方式呢，然后把这个图形给它加入。或者是你可以再做更多的 KML 资料的图层的叠合，然后这个 KML 在 Google Earth 里面把它发展完成了之后，把图示、把资讯都建构好了之后，再把它放进你自己的地图平台。所以这样的 Google Maps API， 大家可以自己在网络上面去看看，它里面会有英文操作版的各个的范例的显示，还有各个的参数到底该怎么设计，每个参数该怎么设定，是不是该有这个参数，都有详细的条列式说明。而他们也出了中文版的操作指南，但是操作指南只限于这个范例的部分，这些 reference 就是没有的，所以大家可以还是用英文版的比较好，这样比较有一气呵成的感觉。除了这个 Google Maps API 之外呢，还有其他的 API 也可以供这个 Google Maps 来借接来加入程式。比如说 ArcGIS 他们也出了 API，ArcGIS Server 也出了 API， 这样的话就有更多的空间资讯还有空间分析的功能能够被加入。除此之外，如果要达到资料的混合的结果的话，你可以加入各个 API， 比如说 Flickr API 可以供你知道各个有受标签的照片，它的加入的位置在哪里？我们可以截取这些相片，用这些 API 方法把相片给它截取下来，或者是你可以知道它们的在地图上的分布是在哪里，这样的 Flickr API 结果。或者是 Facebook 也有出现自己的 API， 利用这个 Graph API 呢，你可以从以自己为本位，然后连接到其他不同的人，在每一个物件都有个 ID 的状况下，再继续查找这样的 ID 的资讯，然后以此就可以让它在地图上做更多的显现。所以大家可以自己来操作看看，看要怎么样来设计你自己的 Google Maps 的 API 地图。谢谢大家。
或者是有一些教材那你就可以去学习一下，把它用到你自己的这个 project 里面那你除了刚刚看到那些网站上面的东西，在 YouTube 里面也有很多的这些教材你可以打进这些 keyword，Google Map API， 就会看到很多人写成的这些 video 的这个教材你可以按照他们的这个的说明按照他们的这个教学的这个内容一步一步的这个学习好，还有没有什么问题？如果没有的话，我想我们今天的课程就